Hello, everybody. So I'm going to do two examples and I'm going to think through them, think out loud. So I need to solve this equation. This is taken directly from Delta Math. There are three sections in there, three problems each, and this is from the middle section. And I know I need to solve, which means I need to get x by itself. All right, well, I've got these fractions. And the only reason I have fractions is because I'm dividing by x plus 1, I'm dividing by x squared plus x, and dividing by x plus 1 again. And I'm wondering, can I factor x squared plus x? And yeah, it factors into x times x plus 1. So there are only really two factors that cause those fractions, x and x plus 1. So I'm going to multiply everything, both sides of the equation, by x and x plus 1, the entire left side and the entire right side. So I distribute x times x plus 1 to this fraction, to this fraction, and to this fraction. 1, 2, 3. Now what happens here? Well, your 3 is being divided by x plus 1 and also multiplied by x plus 1. So the x plus 1s cancel out, or they divide out. And I'm just left with 3 times x. Here, negative 8 is being divided by x and by x plus 1, but I'm multiplying by x and x plus 1. So they both divide out, leave me with just negative 8. Here, only the x plus 1 divides out, leave me with negative 5x times x, which is negative 5x squared. Now I got a quadratic, so I got to set it equal to 0, adding 5x. And now I want to factor. Since 5 is prime, there are only two integers that can multiply to 5, and that is 5 and 1. So if this factors, it's going to factor into 5x and 1x. Now these two numbers have to multiply to negative 8, but in such a way so that when I double distribute, when I do 5x times this, and 5x times x, this term times x, and this term times the last one, I get 3x in the middle. In fact, the 3x in the middle term comes from the outer numbers, 5x times this one, plus the inner numbers, this one times this. So it takes a little bit of thinking here, but eventually you will land on positive 8 and negative 1, 5x plus 8, x minus 1. If you're spending too much time, you'll just have to go directly to quadratic formula. Quadratic formula will always work. Now, I just set each factor to 0 and solve. There are two factors. One of them is 5x plus 8, set equal to 0, so x is negative 8 fifths. The other one, x equals 1. So there are two answers, negative 8 fifths and positive 1. Remember, you're dividing here, so negative 8 fifths will not make me divide by 0, and neither will 1, so I'm safe. Second and last example. Again, I'm solving for x, so I need to get x by itself. What do I see? Well, there's x squared minus 25. I know that's a factorable binomial. That factors into x plus 5 times x minus 5. So there are only two factors that make these fractions exist. One of them is x minus 5, and the other one is x plus 5. Because remember, if you take x minus 5 times x plus 5, you get this fraction. You get this denominator. So I'm going to multiply both sides by both x minus 5 and x plus 5. Now, unfortunately, this is a 1 plus this. So I can't ignore the 1. I had to keep it equal. I had to multiply everything on the left side by this. So x minus 5 times x plus 5 times 1. X minus 5 times x plus 5 times this fraction. And then times this fraction, which gets me all that. So the first one is just 1 times this. Unfortunately, nothing cancels out. So I know that x minus 5 times x plus 5 is just x squared minus 25. The second one, the x minus 5s cancel out. So I'm left with plus 2 times x plus 5, which is 2x plus 10. And in the third fraction, both of them cancel out. Because remember, x minus 5 times x plus 5 is really x squared minus 25. There should be a little 2 here. So those cancel out. So what am I left with? 3x plus 5 times 1. Because remember, these divided out. Now I've got another quadratic, so I'm going to set it equal to 0. I'm going to clean it up first. I got some like terms, negative 25 and 10 make negative 15. Set it equal to 0, so subtract 3x, subtract 5. Do it to both sides, because got to keep the balance. And there it is. Now, I can do quadratic formula, that will always work, but this one is a little bit easier to factor. Are there two numbers that multiply negative 20 and add to negative 1? Yeah, negative 5 and positive 4. Realize you can't do that little trick here. You just can't think of two numbers that multiply to negative 8 and add to 3 because this 5 changes things. So this one was more difficult to factor. But when you have a trinomial where it starts off with 1x squared, then you can do this shortcut, two numbers that multiply negative 20 and add to negative 1. And then I set each factor to 0 and solve. So x plus 4, I set equal to 0, and that equals negative 4. X minus 5, I set that equal to 0, and that leads me to believe that x is 5. But x equals 5 is impossible. Look at the original. The original has 2 divided by x minus 5. What would happen if x equaled 5? Then you would have 2 divided by 0, because 5 minus 5 is 0. Same thing over here. 5 squared is 25, and 25 minus 25 is 0. So x equals 5 is not a solution. But this happens a lot in math, where you get a solution that is actually a false solution. So we call that extraneous. Now, negative 4 is not a problem. Negative 4 will not make me divide by 0. So negative 4 is the one and only solution.